Hello friends, today we'll discuss design of knuckle joint. Knuckle joint is used to connect two rods under the action of tensile loads. However, if it is guided properly, it may take compressive loads too. The joint may be readily disconnected for adjustment or repairs. Application includes joint between bars in roof trusses, joint between link of suspension bridges, joint of wall mechanism of reciprocating engine. Fulcrum of levers, joint between link of bicycle chain. Knuckle joint is not suitable for connecting two rotating shafts which transmit torque. The advantages includes simple to design and manufacture. There are few parts in the knuckle joint which reduces cost and improve reliability. Assembly and dismantling of the part is quick and simple. Let us start with the design procedure. First, we will have to select material. The rod is subjected to tensile force. The yield strength is the criteria for selection of material. Here the material selected is 30C8, taking factor of safety as 5. Compressive and shear stress are calculated. The figure shows a knuckle joint. It includes a single eye that is also known as rod end and a double eye that is also known as forked end. Both the ends are coupled together with the help of a knuckle pin. Now we'll see one by one how it is to be designed when it is subjected to pull P. P is a tensile load. D is diameter of rod, D1 is diameter of knuckle pin. D2 is outside diameter of eye. T is thickness of single eye and T1 is thickness of fork. Assumptions made here are there is no stress concentration. The load is uniformly distributed over each part of the joint. Let us start design procedure. First is to design rod, means finding out diameter of rod. We know P is equal to area into sigma. So area resisting failure is pi by 4 d square. Diameter is d. Diameter d obtained is going to resist failure in tension. But at the same time we know that the other failure is a failure of knuckle pin in shear, which can be obtained by taking section at the knuckle pin, which is going to fail in double shear. So the area resisting failure is 2 pi by 4 d1 square. When there is no clearance is tight, it is not subjected to bending, but when it is loose it will be subjected to bending also. So we will have to calculate bending stress also, means finding out diameter which is going to be safe in bending also. So for that we will have to consider bending of knuckle pin. So after finding bending, that is sigma b is equal to m by z. M is calculated, z is pi by 32 d1 cube. So that is how sigma b is calculated. That will give us the diameter obtained. So we will have to select diameter from bending as well as shear, the one which is going to be safe for both. So we will be to select, we will be selecting maximum of the two. Now failure of single eye in tension. Single eye will fail in tension as shown, and the area resisting failure is d2 minus d1 into t. So P is equal to d2 minus d1 into t into sigma t. So this is how we will be finding diameter of single eye. The single eye will fail in shear also. So for that, shear is as shown in figure. It is area resisting failure is d2 minus d1 into t. Next is failure of single eye in crushing. So the area resisting failure is d1 into t. So the P is equal to d1 into t into sigma c. So these three failure are for single eye: tension, shear and crushing. Then as a single eye, that is rod end, fork end, that is double eye, is to be designed. The main difference in single and double eye, there is only single. Here there are double eye. So tensile, shear and crushing failures are shown. Only thing is that the formula which we use for single eye, there T is replaced by 2T1 here we can see. So the formula will remain same except T is replaced by 2T1. So for tensile failure, the formula becomes P is equal to 2 D1 D2 minus D1 into T1 into sigma T. In case of shear, the area is 2 into D2 minus D1 into T1, and in case of crushing, it is 2 into D1 into T1. So all the formulas will remain same except T is replaced by 2T1 in case of double I. So this is one method of designing where permissible stresses are calculated and dimensions are obtained which are safe in all the stresses. The other method of designing knuckle joint is by proportion. Here all the dimensions are calculated or obtained by proportion. Once the diameter is obtained, that is by considering failure of rod in tension, we will get diameter, and once the diameter is known, we can find a diameter of forked end, diameter of rod end, then thickness of single eye, thickness of double eye. All these dimensions can be calculated by proportion, and then by putting these values of dimensions obtained, we can then obtain the check we can check the stresses induced in the various part of the knuckle joint. So for that, the formula which we have used earlier, only those can be used. So here diameter is calculated, the diameter of knuckle pin as usual, double shear, and then bending, and then D2 and D3 are calculated, that are also by proportion. So once these dimensions are obtained, we can make use of the equations which you have used. For single eye, 3 equations; for double eye, 3 equations. Single eye in shear, tension and crushing; double eye tension, shear and crushing. So by making use of all the equations which we have used earlier, we can check whether the induced stress is within limit or not, and this is how design of knuckle joint is done. But it is always preferred to design it by the first method which we have seen, where the permissible stresses are calculated and other dimensions are checked with the help of permissible stresses. Thank you for watching.